Disrupting Industries. Onna ilaga presentation on Google I/O 2017 extended Sri Lanka. Disrupting Industries to be covered by a gentleman who is passionate about inventing, co-creation, and developing the community of the future. He founded the first ever 3D printing studio in Sri Lanka, 3D Concept Studio. We'd like to now invite on stage the founder, the managing director, 3D Concept Studio. Please welcome on stage Mr. Nissanga Warnapura.
Good morning. So I was a bit worried when they asked me to come in and speak at 3:30 in the morning, because I was thinking maybe I might be speaking to a lot of sleepy fellows, to be very frank. But then just after seeing that exercise 5 minutes ago, I'm pretty sure all of you are quite attentive, right? So before I get started, one of the first few questions I'll be asking is how many of you have heard about 3D printing? Right, so my job is done. Okay, catch you guys later. But I'll ask the second question, which is how many of you have actually used a 3D printer? Hands up, okay? All right, so there's still something that I can probably pass on to you guys. So let me just get this presentation up. Okay, so when we normally talk about 3D printing, everyone thinks a 3D printer looks like a little microwave. That's what everyone usually thinks. And usually that's not the case. I mean, 3D printing has been there for 25 to 27 years, and there's fantastic technology that has come out, as well as different types of speed, different types of materials, different types of applications. And I'll be talking about what's happening around the world, as well as I'll be talking about what's happening in Sri Lanka and what we are doing in the lab. Our studio, we have a little stall here, so you can actually see the product. I'll be talking about what we're doing on porcelain, on metal, as well as different finishing techniques that you can apply, as well as how developers can use 3D printing to launch certain platforms. And today, I'll be very happy to announce certain projects that we're launching, and we're looking for people to join our teams as well. So my topic was disrupting industries, and I feel there's a lot of things happening in this area. So the very first one is this one. This is Design Miami last year, 2016. They did a pavilion, and it was done by the shop architects together with two Tennessee universities who are carrying some of the largest printers that I've actually seen. These printers are the size of a 20-foot, 40-foot container, right? And they can print metal, so they do sintering, so they print on steel. So what you're seeing here is this a metal structure that is welded together using robotic printers. Okay, so again, going back to my first statement, we think printers are the size of a microwave, and it's moving XYZ, and it's a little nozzle that prints. But actually, on robotics, it's a 6-axis robot, like a Fanuc robot, which can print and weld as well as sinter as well. So this is that's the technology that was used for this. It's a huge pavilion done just to showcase that from a design point of view. So I'm sure all of you have seen bicycles, but this project is very, very interesting because this was steel. So steel sintering. It was the same company called MX3D who did a couple of bridges in Netherlands. So what they did was on two sides of the canal, and as you know, Netherlands has a lot of canals. On two sides of the canal, they would have two robots, and overnight they were kind of welding and creating the bridge, and I'll show a picture of that later as well. But the same company who built this bike as well. So this is interesting if you think about design, because once you have different types of fabrication technologies, you can start thinking of different frames. So what we imagined a bike to look like today, it may not look like tomorrow using these new types of technologies. Okay? It's lighter weight, it's much stronger. This is another one. So this was more to do with just normal metal, direct metal laser sintering. This is very light. This entire bike weighs 35 kilos. It's an electric bike, goes up to about 80 kilometers per hour. But what's interesting here is, look at the hollow frame. So this idea really came from prosthetics, which is funny enough. In prosthetics, maybe I'll ask this question and touch wood, it doesn't happen again, but how many of you have broken a hand or a leg? Okay, so the adventurous guys are a bit in the front and the back is a bit conservative, okay? So if you've broken a hand, you normally wear a cast. And usually a cast is very difficult, right? It's very scratchy, and you can't access it, it's not breathable, it's very solid. So what happened was in prosthetics, they started 3D printing casts which have hollows inside. So you can scratch it, you can wash it, it's breathable, it's fresh, but it's strong. It's stronger than a plaster of Paris cast. So that same technology was used for this bike frame. So again, for designers who are out there, it's very interesting because you can get the same strength or even more strength using these kind of materials and these kind of technologies to build certain frames like this, okay? And actually, maybe just to go back a bit, the frame was stated to be 6 kilos. The rest of the bike parts added it to 35 kilos. That's crazy, right? So just to give you a perspective, I try to go cycling sometimes, right? Obviously, it's not having any effect on my stomach, but I try to go cycling. And so first time I bought a bike, it was about 14 kilos, and it was very difficult to ride, okay? So I thought, okay, maybe the problem is the bike, it's not me. So I went looking for a bike which has a lighter weight, and the lightest weight I could find is about 10 kilos that I could afford. And I thought, okay, 10 kilos is really light, and this is for a push bicycle, okay? So the fact that a push bicycle was 10 kilos, and that was an aluminum body, and knowing that this very strong frame for a motorbike was 6 kilos is a great achievement. And this is because of 3D printing and technologies like this. This is a collaboration between Honda and this company called Kabuko, who's a 3D printing company, where they said, look, we want to create modular. The term modular has been coming up quite a lot. Modular in terms of apparel, modular in terms of even for computing, as well as in design for other areas as well. So for vehicles, and we'll be talking about this at the end of the session as well, but this is the project that came out of it. They wanted to create a micro transit vehicle. Obviously, you can't take much passengers in this, these are two-seaters. But the entire idea was, can we create a two-seater? And then from there, can we get into maybe a little minibus, which is about 6 to 8 passengers, completely electric, but the entire chassis was 3D printed, okay? Again, another favorite, which is aluminum, and this was done as a design project. In this case, the entire thing was, it was called aluminum gradient chair, and the entire idea was, how can we use different fabrication techniques to improve comfort, fit, stability, structure, and this was also done from sintering process. So this is just to give you an idea. I'm trying to show you different product categories that came out of 3D printing. It's not always toys. It's not always little plastic goods. So the world is evolving, and I want you to understand that. Right, so obviously, I'm going to talk about 3D printing of houses, and it's still something that's pretty much in R&D. Some companies have done it, especially in China. And what you're seeing here, the reason we put this on this slide is it's a freeform house. A freeform house is it doesn't look like a regular house. So normally in a house, you have certain types of pillars. It has to be straight walls, the typical scaffolding operations. You have to use certain types of brick. If you're using concrete, certain types of stones, steel wire. So this is, the entire structure is 3D printed, and it can be done in irregular shapes. So the entire idea, again, what I'm trying to say is, expect in the next 5 to 10 years, things that you take for granted today, example, things like a chair, a house, a car, a bike, will definitely not look like that anymore. Because now the technology is so advanced that you can create it with the same or even more strength, but in different ways. Okay, so this is that 2 robots I was talking about, MX3D, which is the robots that sinter metal. So this is pretty cool. So what they've said is, next couple of years, they've got a contract from the government which will continue building bridges without any people involved. So can you see, the only guy who you can see in that picture is the guy who's cleaning outside. But actually, there's hardly any operators for this. This is completely run by developers. They give the coordinates, 6-axis coordinate, so like a CAD layout. And pretty much once they install the design for the bridge and you install the robots, it's a matter of just executing that bridge. Right, so this is another example. I thought you would find this interesting. This was printed on a printer. So we have a couple of these printers with us. We're not carrying it today, but you're more than welcome to come and see our lab. This is under the Form Labs technology. It's liquid printing. So we carry a Form 1 Plus. This was printed on a Form 2. This is a camera. It's actually referred to as SLO, S-L-O. It was completely 3D printed. So there's not a single thing inside here that is not 3D printed. So 100% 3D printed camera that operates and works. So again, what they were trying to push and what they were trying to prove is that we are going away from the world where 3D printing was considered for enclosures only. 3D printing was considered for toys only. So we're going away from that. So they're trying to create goods that are complete and functional. Liquid robots, soft robots. We are exploring this on how we can print it using liquid printing and also using things like waxable cast as well as flexi prints, where you can insert these electronics in and they operate in a certain different type of way. This is very interesting area because a lot of people talk about 4D printing. Has anyone heard about what 4D printing is? Any hands? No, okay. 4D printing is reactive printing. So 3D is three-dimensional. The fourth dimension is that an object will react to certain conditions in the weather. So for example, water reactive, humidity reactive, and they will change shape. So for example, if I print a flat panel and I have live hinges, we call it live hinges, the hinges will react if there's water. So if you add water to it, it'll become a box. So from a programming point of view or from a development point of view or from just a basic idea point of view, you can create so many objects that will actually form itself only when it gets to the destination. But you can print it as flat panels with live hinges. Okay, so this example is, what you're seeing here is 1,600 petals. 1,600 petals on 2,600 hinges. Now the reason this is interesting is these petals react based on your moisture on your body. So if you're sweating, the petals will elevate a bit, letting a wicking property. So you kind of sweat it out. So again, technology is getting more and more interesting. And also this dress is very interesting in the way it was printed. For example, you don't have to cut fabric and then sew fabric and have it on a hanger. This garment came out of a tiny little box in a printer. So it came out of a selective laser sintering machine, and it was folded. So it is printed folded. And then you take it out, and you dust it off, and it becomes a dress. So again, the thought process of how you think a dress is made to how a dress is made now. And this dress was made based on a 3D scan of your body. So it's 100% fitting. So you have fit, you have comfort because of the ventilation, as well as the practicality that it's a new generation, new design. It's in color. As you can see, it's a color dress. It's not white. So that's what's happening in the apparel side as well. Obviously, I'm going to talk about bioprinting. There's a lot of conversations going on with some local universities on bringing new bioprinting technology. And this is all about cartilage. So how do you print cartilages? And one of the biggest issues in Sri Lanka at the moment is being able to replace cartilage, especially knee cartilage, after certain accidents. So how do you operate and how do you replace these cartilages? So this is the technology that actually one of the companies that we are very close to is BioBots, and we'll be talking about BioBots as well. Okay, so when we look at few key disruptors in the industry, the names that we came up with, Handsmith, and earlier on in the day, Google was talking about Enable and the community it has on YouTube, and about how the community can help each other. And keeping in mind, Sri Lanka is a post-war country, and I don't like bringing that up again, but we have a lot of amputees in this country, and they definitely deserve being able to get back into or get a livelihood and be able to use their hands again, or feet again, or legs again. So this project here is, again, bionics, but is funded. So this company is something that we look at as a benchmark. You go and donate to this company, and pretty much they make the bionics and they send it to you. Now, to tell you a bit more facts, a bionic hand costs about $50,000. Okay? So in your head, you'll be like, what's the point? I mean, who can afford $50,000? And how many people have to donate to get one bionic out? So in the US, there's about 5,000 amputees per year, out of which only 1,000, actually just 989 get catered. So if you look at it, 4,000 people don't get access to bionics, so they can't have a livelihood, they can't go to work. So if in America it's 5,000 amputees, we had so many years of civil war, right? So there's so many amputees in this country who don't have access. So what I'm saying is, it's a matter of us kind of getting together, coming up with new designs, and we are reaching out to the community as well to say, how can we make affordable prosthetics accessible? So these are three words, okay? So affordability, good design, and accessibility. How can we have platforms like this where we can have contribution and donations, as well as how do you get these kind of products out? So that's one. The other one is this Saphium biotechnology, and I know it's very relevant now because of the recent garbage issue and recycling issue. So this company is looking at creating certain types of materials which easily it's compostable plastics. I know big FMCG companies in Sri Lanka were looking for this technology as well. So when you look out, you see some companies already working on this. Okay. Again, mark forged metal printing, direct metal laser sintering is big. Again, I'll move on. This is a bit of a how can I say area of interest. Okay, so you can't clone people. There's a big issue with that, and big issue ethically, big issue in so many ways legally. But this company is kind of bordering on cloning DNA. Okay, so I'll just show you this interesting fact. So the cost. This is the cost of printing this at the moment. This is at the forefront of 3D printing technology. Okay, so it will cost about $500 to print a protein that you want to get done, but it will cost you about $2 billion to get a human genome printed. And this is actually happening. So this company is very interesting, but has a lot of areas of conflict that is being discussed at the moment. Obviously, Cartesian Company, this is 3D printed electronics, a very interesting area to be in at the moment. If you look at the tiny little desktop printers, which it's portable and you can carry them around. You can print the PCBs. Also, recently they launched their flexible circuits as well. So you don't really have to, from a startup point of view, if you wanted to try out certain types of PCB design, you don't have to buy the minimum order quantity or pay X amount of cost for large electronic companies to provide these circuits for you. Made in Space did this campaign a couple of years ago, from 2012, where they wanted to print stuff in space. Now, the reason I put this slide here is I'm going to talk a bit about digital asset. And digital asset is making sure that we design for printing, design for fabrication, and design the digital asset is going to hold more value than the 3D printing itself, or the CNC itself, or the laser cutting itself. So what happens here is, because space is a very expensive venture, obviously they can't go to space and be like, oh, I forgot to bring this spanner to do the repair, so can you send another rocket up, which is going to cost another $1 billion? What they're doing now is they're sending the digital asset, or the design file, let's call it a design file. They're sending the design file by email to the space station, where they have a 3D printer, and they're printing those spare parts that they couldn't bring along with them, or somebody forgot to put it on the list. Immediately. So I find this interesting. See, the affordability of printing has come down from millions of dollars down to just a couple of $1,000s. So for universities to start doing bioprinting, it's a matter of just investing about $5,000 into a machine. Maybe this is interesting. My wife loves these kind of things. She says, enough about all these plastic and metal and aluminum and steel fabrications and all these things. When are you going to print me a chocolate cake or something like that? So Foodini, this is one of the printers that allow you to print food, especially whatever you put into a nozzle and it extrudes. You can print custom-made chocolate messages for your loved one for Valentine's Day and things like that. A bit gimmicky, but fun. Okay? So food is coming along as well, so you can, whenever you get the feeling I want to have a pizza of a certain type, you just click it to print and it prints it. So a bit early stages on that as well. I had a video of this, but I'm going to go past this. So I met this guy in 2016, October, a guy called Nick. He owns and runs a company called Strakka. Strakka is a Le Mans racing company, a British company. They run from Silverstone. And he told me this amazing story. So he said he was trying to replicate a part of that door for his car, and it was costing him a lot. But he wants so many changes done to it. And the company that was doing the door said, look, the standard Le Mans door I can provide you, but if you want a custom one, it's going to cost you X amount of millions of dollars. So he said, look, I can't afford that. And at that time, he was starting up his racing company as well. And what he did was he used 3D scanning to scan the hinges, and he designed it himself, and he printed it. Okay, so it obviously costed him tens of thousands of dollars to print. But the message he told me is that the digital asset is more valuable to him now. He makes more money from that design than he would from anything else. So lots of people saw that design for the doors, which are lighter weight, more aerodynamic, and more functional for him. And what he did was now he licensed that door design, and he sells it. Okay? So all he owns is a digital file in the computer. So just a normal STL file or .obj file, and he just sells it and licenses it. So this is what I find interesting about digital asset, and that's the message I got from him. So I mentioned this maybe a year or two ago. When we started off, so 2013, lots of people came to us and they asked, here's an object, I want you to duplicate it, okay? And we were like, okay, that's easy. Okay, you give me something, I can duplicate it. Now this is the mindset that we had. The second thing was really iteration. So they said, here's an object, I want to change it a bit. Again, now I saw, okay, now people are changing. They're seeing that they want to add value to a product. Now people walk in and they say, look, I want to create a brand new thing. I don't have anything to show you. I have an idea, or I have a design now. Can you do it? And like this, we've been working with a lot of young and older people where they're asking us for different types of modular product, different types of very basic commodities, like even shaving equipment to different types of combs, which is really funny, right? You don't think, do I really want to reinvent the comb? But you'll be surprised. And they have gone on to sell millions and millions using injection molding as well into the public. So this is the difference that we saw in the consumer and the demand. So what happened over the last couple of years is we also had to adapt. The message I'm trying to say here is you have to keep looking out to see how the world is changing. You have to see how the demand is changing, how I would say, what are people really asking for? What are people really looking for from a material point of view, from a technology point of view? So that's material libraries that we have. Also, we had to learn certain things like post-finishing techniques. So for example, if a student came to us and said, look, I can't afford to spend a lot of money on my product, but I want a smooth finish, so we can't afford to run it on the expensive machines, but we can definitely do a post-finishing and give you a very nicer finish. So those are just a couple of things that we had to learn along the way. So again, our focus areas, and what we spend a lot of time now, is printing a lot of robotics, especially now soft material robotics for lots of students. So they come and ask, can you do a muscle print? Can you print a robotic hand for us? We want to code it to, let's say, catch a ball or do different things. So we are very interested when we have different inquiries every day, and that's why we love what we do. And this is an area that we are just launching a class on this area as well. So you can come and see how a robot is printed, as well as how we do the soft fingers, so that it has a realistic look and function to it as well. Again, this is trying to go into aesthetics of flexible printing. We've been exploring flexible printing, and our team can definitely tell you a bit more about it. It's a big challenge, because that material is very tough to work with, but definitely you can apply it in areas so that people with disabilities don't really have to suffer socially, so that people can kind of cover these areas. This is just an example of post-finishing. So what you're seeing is, all this time, a lot of people look at 3D printing and say, look, it's just white, it's ugly, it doesn't have any color to it, it doesn't look like metal, you can't do anything with it. But there are so many techniques, transferring of colors, electroplating, post-finishing, so let's say sanding and lacquering and painting afterwards. There's so many techniques that we can apply to make it look really good. This is an example. So just a quick example, let's say you're printing on a liquid printer and it costs you X amount of money. Instead, you print it on a normal, very old thermoplastic or FDM machine at about 300 microns even. It looks as horrible as that blueprint over there. But after treating it, you can have a couple of, you sand it down and you apply your first couple of lacquer coats, then a varnish, and then the final product looks really good. So this is how we're trying to localize it so that we can offer more aesthetically satisfying prints to our students. Just a quick example of the difference of what you can do. This is actual print, not done by us, but I want to show you an example of it. I wanted to talk about this as well because this is a company that raised $100 million. Okay? Something very simple. So you have all these platforms and electronics that you can plug into iPads, so like tablets, sorry to use the word iPad, but tablets and computers. And what you can do is in most schools, I mean, not in Colombo, but when you look outside, most of the schools don't have access to computing. And some of the things that we can do is we can do these kind of $50, $100 computers by offering these kind of fabrications around certain platforms so that people can access computers, learn simple things like word processing, Excel, even a bit of coding, right? So something that I wanted to speak about today on education, and like I said before, we'll be launching a lot of classes on 3D design for printing, design for CNC, design for laser cutting, as well as certain robotics classes as well, is we started actually with the kids. So the toughest audience, to be honest, is not the mature audience like yourselves, but starting with people who are about 3 years old. And they're usually very, very difficult to handle, right? So we started a class called Junior Maker Labs just over a year ago. And we do this on every Wednesday and every Saturday. And something beautiful happened, which was we started having 10, 20 kids per class. And we saw the youngest student was a girl who was 2.5 years old. And now she works with electronics. Okay, so she started working with LED strip light. Okay, so that's a very basic thing. But now she started working with, okay, how do I start putting electronics into an object? How do I light it up? How do I put switches? How do I put controls? And how do I make it react? So this is a 2.5-year-old exploring electronics. So what I thought was, look, if the future of Sri Lanka really depends on the younger group of people, male and female, learning these techniques ahead of time, so by the time they go to school and they go to university, they have this entire set of skills. One is design, one is the entire fabrication, making skills, as well as a bit of coding, a bit of electronics as well. So it's not only us who's doing this. There's other IT companies also heavily involved in this. Like I said, we started with the younger audience who are a bit more difficult than the mature audience like you. But you will see our classes coming up, so please register for these classes as well. It's a lot of fun. There's one class which only has 3 sessions for the year. It is image recognition, do-it-yourself quadcopter classes. So register for those because we can only take about 10 applicants per class per session. Okay. So these are some pictures. So as you can see, you start with very basic things. So we wanted to kind of encourage making. So you can't go and push 3D printing to a 2.5-year-old. They'll be like, what am I going to do? They don't even know how to use a computer. So we started working with very basic things. And this is how it evolved. Okay. So again, making, painting, coloring, understanding very basic attributes of making things. So a couple of things I want to mention, like I said. We are launching these classes as well as these last 2 things, which is an innovation pool. We are looking for certain wearable tech applications that we'll be reaching out. We're looking for really smart, really talented individuals to get together on certain wearable tech. And the last one, and we'll launch the video for this. So we've just been approved to bring down this kit. It's called Tabby, and we'll show you a quick video of it. It's a modular vehicle, so it's funded at $20,000. We are bringing the vehicle. We'll show it. So. So this is a project that we are launching today on our site. So we're looking for, again, talented individuals to get together and be part of this project. And I know, again, certain Sri Lankan companies are already working on creating electric vehicles, but this is a different approach to it. Our entire idea is how do you create modular transit vehicles. So you saw it only takes 58 minutes to assemble this. So that's the same video that I would like to see maybe in a couple of months' time with Sri Lankas getting together to create a vehicle in 58 minutes. Maybe we can beat that time. So with that, I would like to leave you behind with the message, there's a lot of areas and applications from 3D printing and assembly and fabrication. And 3D Concept Studio as a company really wants to collaborate with Sri Lankans and the students. So please get in touch with us after this session. So thank you very much. Thank you.